All right, so adding and subtracting rational expressions. So we're going to learn to add and subtract rational expressions and find an equivalent simplified version, okay? And then we're also learning that you need how to find the lowest common denominator, because when you add and subtract fractions, you need common denominators, and it's handy if you pick the lowest common denominator. You don't have as much reducing to do, okay, of rational expressions rather than just fractions that just contain numbers. Okay? So we're going to start off again remembering what we would do if we were adding and subtracting fractions. Okay? And the thing that's different between multiplying and dividing and adding and subtracting is you need a common denominator. So you would look at your three denominators. And you would want to figure out the common denominator. Okay? And we want to figure out the lowest common denominator. No, that doesn't look right. Minus something plus something. Okay. So, anyone think they know what the lowest common denominator is here? Come on. 28? Yes. Okay, so if I want any common denominator, I can multiply all three of them together, and I would get 56, and that would be a common denominator, but I want the lowest. So because 2 goes into 4, okay, the 4 already takes care of the 2, so I can just do 4 times 7 and get the lowest common denominator. Okay? Now I have to adjust the numerator, so you got to remember how that goes. So 7, I had to multiply by 4. So I have to multiply the top by 4 as well. Okay? So you're creating 5 over 7 and 20 over 28 are exactly the same number, they're just written differently. Okay? To get from 4 to 28, I had to multiply by 7. So I'm going to have to multiply the 3 by 7 as well. So 3/4 and 21 over 28 are the same number, just written differently. Okay? And then here, 2 times 14 gives me 28. So I have to do 1 times 14. Okay? Now that you have a common denominator, so this stuff you normally wouldn't show with just numbers, but I want to show it because it's going to be really relevant for what we're doing today. Once you've got a common denominator, you just add or subtract the numerators over the one common denominator. Okay? And that leads you to an answer of 13 over 28. And then you would see does 13 over 28 reduce, but in this case it does not. Okay? So these are the steps you would go through with just numbers. So they're going to apply to rational expressions as well. So when you add and subtract rational expressions, you also have to have common denominators. Okay, so here's our steps. Step 1, factor each rational expression as much as possible and state restrictions on the variables in the denominator. If an individual rational expression could be simplified, simplify it at this time because you make your question easier. Okay, so if you look at a rational expression and you've simplified it, then you can make it easier. So think back to what we just took up. So if this was one of my rational expressions, I could simplify it down to this and then work with this as my fraction. Okay, that's what that step means. If an individual one, so you could say we're adding this to something else, if it simplifies down, do that. Okay? And it doesn't happen all that often, and that's why it's starred, but it's important. Because you can make your question a lot more difficult for yourself if you forget that. Okay? Second step, determine the lowest common denominator of the rational expressions and then create equivalent ones. So figure out what your common denominator is and then multiply the numerators accordingly. Okay? Add or subtract the numerators over the common denominator. Simplify the numerator by expanding and collecting like terms. That's way different from anything we've done in this unit so far. Okay, we've always factored. Now we're going to expand in the numerator and collect like terms. Once we've done that, we're going to check if the numerator can be factored. after we've expanded and simplified? Is it something that can be factored or it can't be? Okay. And then see if you can reduce it with the common denominator by dividing out any like factors or opposite factors using the identity, and then state your answer in lowest terms with appropriate restrictions. Okay, that you found way back at the beginning. All right, so we're going to start off with one where there isn't any factoring involved to get the idea. Okay, and then we'll go through ones that get a little bit more challenging. So these ones, again, there's only monomials in the bottom, but I want to get the idea of how you would go about finding the common denominator. So we'll put in equals here, and then map out what our fractions are going to look like. But what I'm focusing in on is getting a common denominator for all three denominators. So I'd probably look at the numbers first, 8, 4, and 6, and figure out the lowest common denominator of the numbers. Yeah? 24, everyone see that? Okay, so 24. And then they all have, well, it doesn't even matter if they all have x or not. It's not like common factoring, it's the opposite of that. But the highest x is an x cubed, but x goes into x cubed. And what I mean by that is if you do x cubed divided by x, you don't get a negative exponent when you divide. Does everyone see that? And x squared also goes into x cubed because, again, you don't get a negative exponent when you divide. Okay? So x cubed is going to be also part of my lowest common denominator. So that's my lowest common denominator, 24x cubed. So then I have to adjust the numerators. So I have to think to myself, what do I need to multiply 8x squared by to get 24x cubed? What do I need to multiply 8x squared by to get 24x cubed? 3x. So if I didn't know that, I could do 24 divided by 8 to get the 3, x cubed divided by x squared to get the x. Okay, you can always divide. Well, that means I have to multiply 3 by 3x to get the numerator to make an equivalent fraction. So the numerator becomes 9x. And then how about the next one? What do I have to multiply 4x by to get 24x cubed? We multiply 4x by to get 24x cubed, so 6x squared. So that means I have to multiply 1 by 6x squared, which is easy to multiply by 1. And then how about to get, we're going to multiply 6x cubed by to get 24x cubed. Yeah, just 4 because I've already got the x cubed. So just times 4. So 5 times 4 is 20. Okay? So now I've created equivalent fractions, but they all have the same denominator. Once you have a common denominator, you can just keep the one common denominator and add or subtract the numerators. So in this case, my numerators are 9x plus 6x squared minus 20. Then you're supposed to look at the numerator. Oh, sorry, no. Once you have the common denominator, I was supposed to state the restrictions, which I forgot to do. And, I forget that. Well, every year about it. I don't know why. So I can either look here or here. Like I've got my common denominator. What's my restriction? So I'm only looking at the denominator. Yep.
X can't be 0.
X can't be 0, because this is 24 times x cubed. So 24 times 0 cubed is the only way I get 0 in the denominator. Okay? Now I want to look at whether the numerator is factorable or not. Any suggestions on how I would know? Can I factor the numerator? Yep.
Well, the numerator never negative, so denominator.
Denominator I can't because it's just one term. How would I figure out if I can factor the numerator? Well, do you see that I've got an x squared and x in a plain number? So can I reorder these so that they look like this instead? As long as they've got the same sign in front of them. So I've got the x squared term first, and then the term with an x ending, and then the number. So now if I'm using my factoring flow chart, and I'm just looking at the numerator alone, is there a common factor? No. Count the terms. 3. If it were able to be factored, what type of factoring would it be? Complex trinomial, because there's a 6 in front. So I don't know whether it is or not, and this will happen. If it were able to be factored, I would need 2 terms that multiply to negative 120x squared and add to positive 9x. Okay? So 1 has to be positive and 1 has to be negative, and the bigger one has to be positive. So I'd start with my calculator. 120 divided by 2 is 60. 120 divided by 3 is 40. 120 divided by 4, 30. 5 and 15. No, sorry, that 8 and 15. Sorry, 120 divided by 5 is 24. That's still too far apart. 120 divided by 6. So I'll start writing them down to see if we get to 9 ever. So the bigger one has to be positive, so negative 6x and 20x. That adds up to 14x. Everyone agree? And I'm going to divide by 7. Doesn't go in evenly. Divide by 8. So it's going to be negative 8x and 15x. And that adds up to 7x. So you see I go from 14 to 7. So it can't be factored. Okay? Would have to be in the middle of those two. And 7 doesn't go in evenly. Okay, so since it can't be factored, all you do is state your answer with the restriction that we found. I just add the restriction on there, but I put my factoring work there, as long as x is not 0, and that's your answer. So sometimes the numerator will be able to be factored, sometimes it won't. All right, B. So now our denominators are binomials. Okay? So you find a common denominator by multiplying. So this unknown number d plus 5 multiplied by this unknown number d plus 2 will be our common denominator. We don't know what they are, so we can't really do any better than that. Okay? Multiply them together, and we know we get our common denominator. And then we have to adjust our numerators. So this, to get from this denominator to this one, I had to multiply d plus 5 by d plus 2. So I have to multiply the top by d plus 2. Okay. Here I had to multiply the bottom by d plus 5, so I have to multiply the top by d plus 5. And once we have our common denominator, we want to state our restrictions. So probably easier to do it on the next step down when we only have it written once. So then we're going to, in this case, subtract the numerators over the common denominator. And now let's state our restrictions on our common denominator. So where do we think the restrictions are going to be here? Yep,
D can equal -5 or -2.
correct. Did everyone see that? Yeah, I could have done it way back here. D can equal -5 or -2. See how I could have done it here? Okay. All right. So let's look back at the stats. So factor each rational expression. There was no factoring we could do. We couldn't simplify any of them. Determine the lowest common denominator. We did that. We did our restrictions. Add or subtract the numerators over the lowest common denominator. We did that. We're on step 4. Simplify the numerator by expanding and collecting like terms. This is something we're not used to doing. Expand the numerator. So how do I expand d minus 1 times d plus 2? How do I expand that? Back to grade 10 now. Remember that? Multiply the binomials together. Okay. So that's going to give us d squared plus 2d minus 1d, or just minus d, minus 2. And then minus 2 times d plus 5, I just need to use the single distributive property. So I'm going to get minus 2d minus 10. So that's my expand step for the numerator. And then the simplify step is way back to grade 9 where we collect like terms. So is there any other d squared terms? No. My d terms, so I've got positive 2d minus d is 1d, minus another 2d is minus d, minus 1d. So minus d. And then I've got minus 2 minus 10 is minus 12. So that's our, oh, okay. Thank you, 24.
24?
Yeah.
Okay.
All right, so now we've simplified and collected like terms. So the last step is to check and see if the numerator can be factored. So we're asking ourselves, can we factor that? So we use our flowchart. Is there a common factor in the numerator? No. Count the terms, there's 3. Is it a simple trinomial? Yes. Okay. So that means I should be able to factor it if there is 2 numbers that multiply to -12 and also add to -1. Okay. And those numbers are -4 and 3, good. So -4 and positive 3. And then if I'm lucky, I can reduce here, but I can't, right? None of the factors are exactly the same. So all I have to do then is restate the restrictions. D can equal -5 or 2. Okay? If I'm lucky, one of these will go with, cancel out with one of these, and I can reduce a bit more. That doesn't happen all that often. This is called simplified factored form. Okay? Simplified factored form. Which is what we're going for in this unit. Okay, one thing I wanted to point out was the biggest mistake I see with adding and subtracting is people wanting to cancel in this step. Like they see a d plus 2 here and they want to cancel those, and they see the d plus 5s here and they want to cancel those. Why can't you do that? Does anyone know why that's not? Yeah? Right, so in the top here, is this 1, 2, 3, 4 things multiplying together? No, it's 2 things multiplying together, subtract another 2 things multiplying together. The only time you can just cancel is when everything in the top is multiplying and everything in the bottom is multiplying. So it's this minus sign here that is a barrier. It says I cannot divide top and bottom until I deal with that subtract. Okay? So instead you have to go the route of expanding, simplifying, and then factoring, and then finally at the very end checking if you can reduce. Because now the whole top is just something multiplied by something else over something multiplied by something else. Okay? So that minus sign or plus sign, depending whether it's add or subtract question, is preventing you from doing that, even though it looks so tempting. Okay? All right, next one. Factor everything as much as possible as our first step. So 5 is just a monomial, you can't factor it. X plus 5 also can't factor it. 2x minus 5, oops, can you factor it? Nope. But how about x squared plus 9x plus 20? Can you factor it? Yes. It's a simple trinomial. We could do restrictions. What would my restrictions be? Yep.
X can't be negative 5.
Negative 5 or negative 4? Yes. Okay. All right, so there's my first step. Can I reduce either of these fractions before I go on? No, this one can't be reduced, and even after I factored, this one can't be reduced either. Okay? You don't have like factors in the numerator and denominator. So I'm stuck with them the way they are. So now I want a common denominator. Now, common. Do you see that these factors are common between the two denominators? Yes. Okay? This one's different. So my common denominator is going to be x plus 5 times x plus 4. Okay? So my common denominator is going to be x plus 5 times x plus 4. Okay, so you see to get from this denominator to this one, I had to multiply the bottom by x plus 4. So I have to multiply the top by x plus 4. Here, I already had that denominator, so the numerator stays the same. I already had this, so I can just leave the numerator the same. The next step's really important, especially if it's a subtract question. I'm going to put a little star beside it. So the next step says to add or subtract the numerators over the common denominator. So 5 times x plus 4, subtract, I want to subtract 2x minus 5. How do I show that? Yep, put brackets around it. Love it. Okay. If I forget the brackets, it's going to look like I'm just subtracting the 2x and I'm ignoring the minus 5. Okay, so you need to have those brackets. Perfect. So the next step is to expand and simplify the numerator. Okay, so I've got a distributive property here. And then this, I've got a distributive property here that I can't forget about either. A negative is like a negative 1. Okay, multiplying each thing in the bracket. So I get, if I expand the first part, 5x plus 20. And then the second part, I get minus 2x. And then negative 1 times negative 5 is positive 5. Okay? So over x plus 5 times x plus 4. And then I want to collect my like terms. So 5x minus 2x is 3x plus 25 over x plus 5 times x plus 4. Can the numerator be factored is the next thing you check for. The only possibility would be common factoring, but 3 doesn't go into 25. So we're done. We just need to restate our restrictions that we found way up at the beginning. And that's our answer. Okay. D. All right, so step 1, factor each numerator denominator as much as possible. So 2y is just a monomial, so it can't be factored. Y squared plus 3y minus 4. I'll let you guys try the factoring there. Does anyone think they have the bottom of the first one factored?
Y plus 4, 1 minus 1.
Yes. How many people got y plus 4, y minus 1? Excellent. Good. All right, and who thinks they've got the denominator of the second one factored? Jack?
Y plus 4, y minus 1.
Yes. Very good. How many people recognize that as a difference of squares? Excellent. Okay, good. All right, so what about restrictions? I have to look at the denominators of each one. Molly?
Positive or negative 1 and negative 4.
Yes. How many people got positive or negative 1 and negative 4? Awesome. Okay, so now we would look individually and see if either of these could be simplified, but they can't be, unfortunately for us. Okay, so now we have to try to sort out our common denominator. So I'm going to highlight things that are the same in the denominator. So y plus 4, is there a y plus 4 on this side? No. Y minus 1, is there a y minus 1 on this side? Yes. And then there's also y plus 1. So there's 3 different factors. Okay, so that means our denominator has to have 3 different factors. It's got to have a y plus 4. It's got to have a y minus 1. And it's going to have a y plus 1. So there's our common denominator. It contains all 3 factors. Okay, so now what you want to do is figure out what you had to multiply this denominator by to get that denominator. The one that was missing, right? So the one that was missing was y plus 1. So I have to multiply the top by y plus 1. And here, the one that was missing was y plus 4. So I have to multiply, wait a sec, it should be a plus 4, right? Yes. I have to multiply the top by y plus 4. All right, so now all I've done is adjust the numerators and create equivalent fractions. So if I'm following my steps, the next step is to subtract the numerators over the common denominator. So I just write the denominator out once. And then I subtract the numerators. And that looks really messy. Okay, so now I expand and simplify the numerators. This part is easy, but this part is not. I have to subtract the product of these two. Okay? And to multiply these two, I have to do the double distributive property of FOIL. Okay? So watch my thinking here. So I'm going to expand that and get 2y squared plus 2y. Now I'm subtracting this whole thing, but I have to multiply first, so I'm going to keep the product in brackets. Okay? Because I have to subtract this whole product here. So y times y gives me y squared. Y times positive 4 is positive 4y. Positive 4 times y, positive 4y again. Positive 4 times positive 4 is positive 16. There's my first step towards expanding and simplifying. And then I still have the common denominator, y plus 4, y minus 1, y plus 1. Then I'm running out of room, so I'm going to arrow up here. So I'm on this stage here. So what I'm going to do is collect those like terms inside the bracket. So I've got 2y squared plus 2y minus y squared plus 8y plus 16 all over y plus 4 times y minus 1 times y plus 1. Okay, so all I did was combine the 2 plus 4y. Now I'm going to expand by multiplying this negative, which is really like a negative 1 multiplying everything in there. So that's my next step down. 2y squared plus 2y minus y squared minus 8y minus 16 over y plus 4, y minus 1, y plus 1. Now I'm going to collect my like terms. So I've got 2y squared minus y squared is y squared. Positive 2y minus 8y is negative 6y. And then minus 16 over y plus 4 times y minus 1 times y plus 1. So it took me 1, 2, 3, 4 steps just to do expand and simplify the numerator. Okay? Because I do all that algebra carefully. So now I'm on this very last step where I check and see whether I can factor the numerator. If I could factor the numerator, what type of factoring would it be? A simple trinomial. So are there two numbers that multiply to negative 16 and add to negative 6? Yeah. What are they done?
Negative 8 and 2.
Good. So I can make the top y minus 8 times y plus 2 over y plus 4 times y minus 1 times y plus 1. And then I check and see, do any of the factors in the top divide with any in the bottom? That'd be nice, but they don't. So I just restate my restrictions. Y can't be negative 4 or positive or negative 1. Okay, that was a long one. Took a lot of time, but if you just know what you're doing and follow through on the steps, you can do it. It just takes a long time to do it. Okay? All right, this one's actually a cool one. So let's start this out here. All right, what I'd like you guys to do is just try to factor the numerator and denominator. All right, so who thinks they factored the denominator of the first one correctly? Or what's to try? Give me an answer. Thank you. That's awesome. Thank you so much. Right, common factor of x. How many people got that? I thought tons of you as I walked around. Good. And then here the common factor was y. Y minus x. Yes? Okay. How about restrictions on the denominators? Anyone got this one restriction you found? Yep. Y can't equal x. Okay, could I have had x can't equal y as well? That one comes from either here or from here. Do you see that they would have the same restriction? If x or y equaled each other, they'd be 0. Any other restrictions? That?
Both x and y can't be 0.
Right, x can't be 0 because of that x there. And y can't be 0 because of that y there. So I should have 3 restrictions. Okay? These two happen to have the same restrictions, so that's why I don't need 4. And then there's 1 there and 1 there. Does that make sense to everybody? Now, before I go and do my common denominator, wouldn't it be nice if these were both x minus y's instead of being opposites? Wouldn't it be nice if they were both x minus y's? Yeah? Or they were both y minus x's, one or the other? Because then I wouldn't have both of these in my common denominator. I'd only have one of them. Does everyone see that? It would make my common denominator easier. All right, how do I achieve that goal? If that's my goal. David? The identity. So which one do you want to do it on, the first one or the second one? The second one, so you want to leave the first one the same. All right, so how are you going to use the identity here? What's your next line going to look like, David? Everyone see that? So if you use the identity, b minus a equals negative a minus b. Okay, and you need that extra set of brackets, otherwise it'll look like a subtract sign. Okay? So I'm going to use a couple of steps here before we get down to it. But see this negative 1? I can multiply it by the y. Yep.
Would it also work if you put the negative in front of the y?
Yes. Okay, that's what I'm doing next. Okay? But I just want to show all the steps for the people at home and for you guys. So minus, and then, so that negative 1 can multiply the y and give me negative y. Now, when I have a negative sign, I can choose whether it's in the denominator, out front, or with the top. I never, ever, ever choose to leave it in the denominator. Okay? I either bump it up to the top or I'm going to put it even with the fraction bar. What does anyone suggest here? Okay. So I'm just going to do that. Everybody get there? Okay. Love it. All right, so now I'm going to decide on my common denominator because now I can color these both exactly the same. And then I've also got that, and I've got that. So I've got 3 different things for my common denominator. So I'd probably write it as xy times x minus y. Does that make sense to everybody? Okay. So then I look at what did I have to multiply the numerator of the first fraction by to get the common denominator? Y. So this top's going to become 3y. And then what did I have to multiply the second denominator by to get the common denominator? X. I have to multiply the top by x. All right, so now I subtract the numerator, so 3y minus negative 4x over xy times x minus y. What happens when you subtract a negative? It becomes a positive, or you can think of multiplying by negative 1. Either way, you're going to get 3y plus 4x over xy times x minus y. And then the last stage is to check whether the numerator can be factored. No, so I just restate my restrictions. X can't equal y. Actually, no, I think he said y can't equal x. It's the same thing, or 0, and also x can't equal 0. Okay. So this identity can help you make an easier common denominator, right? So instead of having an x minus y and a y minus x in it, we just had one of the two using that identity, and then bumping the negative up to the numerator. All right, last question. All right, I'm going to give you guys time to factor. Who got the first denominator factor? 7?
Plus 3 plus 6.
Yes. So simple trinomial, multiply to 18, add to 9, 3 and 6. Awesome. And the second denominator factor, Juliana?
X minus 3 and x plus 1.
Perfect. Another simple trinomial. So then based on that, what would be my restrictions? Common denominators of each fraction. Negative 3, negative 6. Positive 3, so I can make that plus or minus 3, and negative 1. Pretty good? Okay, the very first step says factor each rational expression as much as possible and state restrictions on the variables in the denominator. We did that. Then it says star. If an individual rational expression can be simplified, simplify it at this time. Can either of these rational expressions be simplified at this time? Yes, both of them can. Everyone see that? So this one becomes 1 over x plus 3. And here, this one becomes 1 over x plus 1. So instead of having to make a common denominator that had 1, 2, 3, 4 different factors in it, which would have been probably stressful, now our common denominator only has 2 different factors in it. Okay? Because we read step 1 carefully, and we realized that we could make the question easier on ourselves. Okay, that's the first time that's happened. All right, so now we have our 2 different factors to consider for our common denominator. So our common denominator is going to be x plus 3 times x plus 1. So for the first one, I had to multiply the bottom by x plus 1, so I have to multiply the top by x plus 1. 1 times x plus 1 is still just x plus 1. Okay? And then same thing here, I had to multiply the bottom by x plus 3, so I multiply the top by x plus 3. Now I add the numerators over the common denominator. And expanded, simplify, well, it's already expanded, but I have to simplify it by collecting like terms. So if I do that, I've got 2x plus 4. Then I check and see if the numerator can be factored. Common factor of 2. Then I check and see if it can be reduced, but it can't. So then I restate my restrictions from the beginning, which were plus or minus 3, negative 6, and negative 1. And that's how I'm subtracting.